So, everyone, hello! This is your favorite Polish mad lad, Girali. So, let's do this. Let's make a tutorial about movement. So, what's movement? Movement in video games, you know what it is, but in network games, don't know. And especially in on Photon Bolt. So, for use case of our network architecture, we will use commands. Commands are simply a thing that you can add by clicking on your right click on your mouse in Bolt assets. So commands are mainly made to send the inputs to the server, to make sure that the server interprets the inputs that you have made, and to make the input work like it work on the client. That prevent simply the bad players and the cheaters of cheating on your game. So they can speed hack. They can speed hack because when you are speed hacking, your information is verified by the server, and then it had been sent to your client the correct position, and your position are corrected on your player when you are a client. So let's create some inputs here, 6 in total, 1 for forward, 1 for backward, 1 for the left, and 1 for the right, and 1 for the yaw, and 1 for the pitch. Those inputs are simply your keyboard inputs and your mouse inputs. So here the yaw and the pitch are so the X rotation and the Y rotation of your mouse. In the results, we want to create 2 results. So 1 for the position and 1 for the rotation. Position, rotation. So position is vector 3, and you can compress it like this. No, 1, 6, 3, and simply, yeah. So normally the quality of the video is better in these episodes. I found the option to have the full resolution on OBS. So we have created our player command. Now we want to make some scripts, because commands are useless alone. So create some scripts. Let's create first a folder. Oh, come on, Unity. Don't be a kid. Player. So in our player, we're gonna create 2 scripts. One player controller, so it will be our main scripts for everything we do on our player, as it is our source. I will name it like this, and the player motor that will interpret what we have on our player controller. So let's open our player controller, because it is better like this. So here, yeah, reload. So yeah, we can undo in our player motor this, and in our motor this. So we can put this away, and we can make it like using Bolt library, yeah. And here we're gonna just simply add our entity behavior, physics state. So here, to first, before we are gonna start, we just want to make sure that every variable are assigned in our code. So mainly what we're gonna need will be the keys and the input information here. we're gonna need a reference of our player motor because we will need to calculate our position and everything. We have a variable to know if we have the control over the entity. It will be useful later. And a mouse sensitivity because we want to make our player move correctly. So at first we're gonna assign of course our player motor because it will be on the same entity and everything, and it's important that we assign in the awake or components. So here what we're gonna do, we will gonna override a function that is named attached. Attached is simply a function that is trustful on our network, because this function will know if we have the control over the entity, if it will know everything when our player is spawned. Of course, it doesn't know about states, because states are not synchronized at this moment, because synchronization of states are different. But in this function, we will need to assign our transform to our transform network transform. So what this line says to us, at first we're gonna need our states that are referenced in the entity behavior. What is a state is simply all the variables we have synchronized on the player state, physics state. So here the transform, and we can simply get it to synchronize it on everyone. So remember, if you do something like set state dot add callback, add animator, set transform, set teleport, everyone needs to know it, because otherwise it will just be useless. It will be useless because only one client or only the server will know about it, and when the player will want to synchronize it, other players will just have the synchronized state transform, but it will not know what transform it will need to synchronize with. So a long phrase to say nothing, but you know, it's needed to understand better our thing. So now we're gonna do a function that we are naming pull keys. Pull keys is simply a function that gives the ability to get all the keys from our keyboard and our mouse. So here the x-axis, of course, so I have nothing to say about this. These are simply a get key on the correct keys on our keyboard. Here we want two things. So the yaw, so the y-axis rotation of our player, and the pitch. So the pitch is the x-axis rotation of our camera. So here the yaw is calculated like this, knowing the movement sensitivity. We just multiply the row axis x, so x is the length of our screen, because you know, y is the height, and it will be modulo 360 because a rotation is in 360 degrees. The pitch is just clumped in the following variables, because we don't want to go over our head and to look behind us, and under our on a body to look behind us. So we clump the values between these two. And this is all we want for our pull keys. Now what we want to create a void update function in which we just wanna know if we has the control over our entity. We will gonna need to pull our keys. So what does it mean? This means that we gonna need to pull our keys only on update. Why only on update? Because update is more responsive for inputs other than fix update. Fix update is the function which are other network function based on. So it's another update, but it's not as responsive as update for inputs, only for inputs. Otherwise, fix update is normally called more times than update. And here we gonna just need to know if we has the control over our thing. If we has the control here, we say true if simply our entity dot has control. So if our entity, when it's attached, it has control, we gonna just say true here. Important because otherwise we could not move our player. So now what we're gonna need? So now we're gonna need to send our inputs to the server. So like an event, we're gonna create a simple thing like here. So in the simulate controller, we just wanna create a variable named iPlayerCommand input. Here, let's just name it input, and like a command, like an event, we're gonna just need to create to make a player.create playerCommand.create like this. Nothing to put in the parentheses because no parameters. And now we were gonna just fill our input with the forward, backward, right, left, and yaw pitch information, and we're gonna just queue it on our entity, because queuing inputs are important, because inputs need to be received in the correct order, of course. And to finish it, we're gonna just override another function which we're gonna name execute command, and this simple little thingy is a function that will help us to know if we are the server that we who received the command, or are we the client who received the correction of our position, for example. So here we're gonna at first do the network part, but in order to do the server network part, we need to make our player move. So for this, we're gonna need some variables like here. So those are good. In here, we're gonna need to get our rigid body, of course, like every component that we have on our entity. And we want to use it. And now we're gonna I will pass some code because it's very long to simply write. But first we're gonna need a state. So state is what? Is simply a result of our player movement. So in which we're gonna just pass the position and the rotation of our player. Next, what we're gonna need? We're gonna need a function that we will name execute command, like before our other function that we has override. It's simply a name, a function that we'll be using for executing the different inputs. And in here, we're gonna interpret simply our different inputs. So at first, what we're gonna need? We're gonna need to determine a moving direction based on the different forward and backward information and left and right. So of course, it's a compressed version of if forward, so forward equals to transform dot forward, and etc. and etc. So we don't want that, so we just simply do something like this. Now we just want to make it sure that it's working, so we're gonna just do something like move direction dot normalized to make sure that the moving direction is simple normal vector, and then we will multiply it by the speed. So the speed is here because we want to modify in the future the speed. And when it has everything done, the moving direction is correctly calculated on the server and the client. We want to assign it on the velocity of our rigid body. And now for the camera and the rotation of the player, we just want to make sure that the camera.transform.local angle is on the x-axis is the pitch, and the transform of our player is the rotation equal to the quaternion Euler y-axis yaw, and that's it. So here we have everything done. Simply now we need to have our state motor to be returned for server purposes. So simply we will return our result of our movement in this function. So let's return it like this, and now we are capable of doing something on our player controller. So now we have done that on our player controller. We just want to pass the following inputs that we have registered before in the pull quiz on our simulate controller with the player.execute command, and it will just move our player when we will we will insert some input from our keyboard. So now what we want to do is simply to make sure that if we are the server here, want to create a motor state in which we want to be sure that we will pass the following. So before that, we just want to make sure that we converted our command that we have received on the server to a player command, so like this. And now, when we are on the server part, so when we are not the entity controller, like this, we want to be sure that now the player motor.execute command, and let's pass everything that we have received from the command. So we just do command.input forward, backward, and etc. We passed it in our execute command. So the server simulate on its side the movement, and now we can just pass the results of our movement in the motor state that we have created here. And to finish, we of course just want to make it sure that it is resent to the player. So we just want to make cmd.result.position equal to motor.state.position, and we can do the same for the rotation. So rotation here is equal to the rotation of our motor state, and everything's done. So now we are sure that we are resending everything that we want to our player. Now our player needs to interpret this information. So in order to interpret this information, we just want to head to player motor and to make a set state. What a set state? It's simply what I said. It's a correction of our position and rotation on the network. So in order to make this work, we're gonna just add two new variables. So the last position on the server, and if we are on the first state, because we will base our correction on interpolation in order to make it more smoother and to look great on the client side. So let's make it good. So the last server position here will so at first we have the rotation. It's corrected like normal, so it has no problem. Normally we don't do any correction on it, so there is no nothing to be alarmed on. So here, if we are on the first state, we just want to teleport our player in the correct position, because mainly we don't want a player to be interpolated from 0, 0 to the spawn position, because otherwise we will see on the scene a traveling very fast, and if you have a very long distance, it will not look professional and finished. And of course, we don't want to read any false results, because sometimes your server sends you a false result, or simply you received a result that is incomplete, and it's translated by just simply receiving a position vector.0, and this is not what we want. So we are not reading and we are not doing anything if we have received a false result. And if we are not in the case of our first state, we just want to be sure that our position is corrected with a simple interpolation like this. So from the last position on the server minus the transform position of our player, and we multiply it by the half of the this distance. And of course we add it to our position, current position, of course. So now what we're gonna do? It's simple. We just wanna do a player motor dot here. Oh, come on. Sorry. Dot set state, and we just want to insert our results. So command dot result dot position and command dot results dot rotation. And it will correct it automatically on the player motor. And that way you are sure that no one can speed hack your game. I think. I'm not sure, because I didn't have any speed hacker since now, so I think it works. So now we are sure that everything is working. What we want to do? We want to do something in addition. So make sure the view of the player is correct. So here we're gonna just add a private camera reference for our scene camera. So scene camera, and of course we want to have an accessor for it here. We don't have any setter for that. And our player, we want to make sure that we have a function that is named public void init. Init with a boolean is mine init. And in this function, we want to be sure that if we are the controller of this object, we want to be sure to set it active in order to see and have the camera correctly set. On the controller part, we're gonna do the same thing. So we are gonna create a public init function that will be boolean is mine. And in which we're gonna just lock our mouse, and in the second part we're gonna just deactivate the camera on our server. So let's on our setup controller. So make the code like this, look like this, and Of course, in the attached part, now we're gonna init simply the entity with the entity has control. And here we're gonna just do something like this, player dot init and entity dot has control. So why we doing it like this? Because we want to execute every function in the correct order. So later we're gonna have some color settings for the player, we're gonna have some visual settings for the player and everything, and this is why it's important that we do init function that is executed in only one function. It's more clear like this, and is better when you want to make sure that the execution is in the correct order. You can control your order, you can control everything over your scripts, so it's very important. So here we're gonna enlarge our playground, so let's make it 0.1. Let's make it 2020. Here we're gonna want to, on our setup controller, set the camera. On our player prefab, what we're gonna want to do, we're gonna want to add a camera in the 0.5 y position axis, and here we want to add two new scripts, so player controller and player motor, and of course bind the player motor to our prefab. So now we have our prefab. I don't forget to make sure the camera is deactivated on the player, so we don't see other player when we spawn. And now we have everything done. Let's verify the script. So don't forget here to make it sure so it is mine, of course. Because otherwise it will be executed every time we connect with a player. So yeah, now we are sure that the camera is activated and is false on every other player. And so now we can make the game build. So the game will build for us, and when the game has builded, we can open an instance for the server and another instance for the player. And so we have everything done, I think. Connect, and we can hide the console, of course. And let's see how it's working. So we spawn a player. So we have a player correctly moving. We can spawn another player. We have another player. He is moving correctly. And that's it. We have our tutorial finished. Is that awesome? Of course it's awesome. So now I will say goodbye to you, to every one of us, you. So don't forget to subscribe, leave a like, check our other social networks like Instagram, Twitter, and remember to code every day. See you soon.